Okay, so I'm gonna give you the shape file of the new city that we are gonna work in. It's called Lumberton. It's like a small city in Robeson County in North Carolina. This is the shape file from the National Structure Inventory. So you're gonna have a National Structure Inventory shape file, like Nueces counties and all the projects that we worked on. And I'm gonna give you the hazard map, same way. I'm gonna give you flood depths and water surface elevation. And you all know how we can use these hazard maps to get the flood depths above the ground and flood depths above the first floor elevation. That's what we need, okay? So I'm gonna give you all these information so you can subtract the flood depth. And from the flood depths, you can get the other information. So if you guys remember the mapping algorithm, do you remember when I gave you a MATLAB code, it's called mapping? So the mapping, you are gonna just replace the file that you have for Nueces County and put the new shape file, run the MATLAB code, is gonna give you a mapped a shape file for these buildings. Like, do you remember we had an algorithm that can add a field, it's called the building archetype, and in this field, you put archetype 1, 2, 3 up to 15. All right. So once you are done with this step, you are gonna use a MATLAB code. It's already shared. You should have used it before, right?
I downloaded it. I downloaded something called map. Is it the same format?
Yeah, it's the same mapping algorithm that we used for the other project.
Okay, so
It's called building mapping. So from the city, Nueces County that we worked on, I gave you a shape file, and you suppose that you have used this. You read the shape file, and I give you that code. It reads the information inside the shape file, and based on this information, it assigns a field that's called the building archetype. So if you remember, it has some if statements. It says like if the building is residential, it maps the archetype from Hazes commercial 7 and add our archetype, which is number 12. Okay, so that's the same one. So you're not gonna do anything except changing the name of the shape file. By the way, this mapping code, I use it for any city, like I have some projects for other cities. They get this code, change the shape file, I run the code, I get the mapped buildings. It only works for National Structure Inventory. Okay. But if I have other shape files from different sources, I play with the code a little bit. I have to develop new one because I'm reading the fields in the shape file with the field's name in the shape file from National Structure Inventory. If I'm having this shape file coming from different source, I have to change the names. Okay. All right. So that's basically what I would do. I would just like change the shape file and rerun the same code, and at the end I'm gonna have an archetype assigned, one for wind, one for flood. What we use right now is for flood. Maybe later we're gonna use the wind archetype. Okay. All right, so that's a step number 1. Step number 2, once the archetypes are mapped, we need to do vulnerability analysis. But to do vulnerability analysis, I need to know after the mapping, I need to know the flood depths, because without the depths, you're not having something to start with. Okay, so the mapping only tells you what archetype is each building, but doesn't tell you what is the flood depths of each building. So you take this shape file, the point shape file, with the hazard map, overlay them together, extract the flood depths of each building. Okay, so once you get this done, you are going to take it to the next level. So I gave you a YouTube video to watch last time. You will say, oh, that's like a 6,000 line code, but it's not that way. Actually, it's repetitive. You're gonna see like it's a very small, but I'm repeating some pieces the same 10 times, and I'm gonna tell you why. So it's not 6,000. You are gonna copy paste a lot of these codes. First, it is kind of a code that is similar to the one that you worked with for Miami, for Nueces County. So you are gonna read the same shape files that we read from before, okay? So you're gonna read the same Excel file. Do you remember when we started the coding last time, when we're doing, like you were reading some Excel files for the losses, for the fragility parameters, for the replacement cost. This is the first shape file that we start reading. Except I added another Excel file to read, this one, it's called loss. There's loss, M2, 2D, that's Excel file that we read from before. The second one, it's loss, and I have EC. EC is like an abbreviation for elevated components. So right now, we are gonna do today mitigation analysis. So I'm reading a new shape file. Like, let's say, I'm reading Excel files. I have here the flood depths. I have here the losses, and the losses up to 100%. Let's say this is 50%. And this is the loss curve, the original one, something like this, all right? And you did some mitigation to the building. What kind of mitigation? Let's say you elevated the water sensitive component, like you elevated the AC unit, you elevated the electronics, like 6 hours before the flooding, the flood warning, you try to elevate every water sensitive components. Like you take all your laptops, your phones, your printers, your TVs, and you put them in the attic, or you put them in the second floor. And your fridge and maybe your stove, you took it and you put it on like a blocks or something, stuff like this. Maybe you will say, as I said before, that's not much, but it can save you $10,000-$15,000. So when you start your recovery after the flooding, you don't have to buy these components again, right? So this is, if you didn't, this is the original one. If you have all the components in the same original place, but let's say you elevated the water sensitive component. What do you think? This curve is gonna be down or is gonna be up? No. It's gonna be down? Okay, so let's say it's gonna be here. So if I'm having here, let's say flood depth's 2 meters, and you go up, this is gonna give you, for example, 15%, but the original one is gonna give you, for example, 35%. So you reduced by 20%. So what I did all the analysis for the 15 building archetype, not the 15, the residential, only the residential. I didn't do anything for commercial. Commercial usually don't do anything. All right. Sometimes some commercial, they build a flood barrier around their building. So they do something, but they don't elevate components. Usually homeowners that they elevate their components, or they take their belongings like the jewelry, the electronics, whatever. All right, so what I did the analysis, and I have one original one, and that's the verse Excel file that I'm reading. The verse Excel file have the loss function, the original one, and I have another one for the elevated component. So I'm reading both. Why? Because when I do mitigation analysis, I want to do analysis with and without, and I see how much loss reduction that I have for the entire community. Did you guys got that? Okay. So, and then I'm reading the same thing again. I'm reading the depth 2D, like I'm reading the x-axis. I'm also reading the damage state parameters. If you guys remember the fragility parameters for the 15 building archetype, I have lambda and XC for each one. So I'm reading the same thing. But the thing is, I'm gonna do different types of mitigation analysis. I'm gonna investigate what if the homeowner or the building or the business owner was able to build a flood barrier around the property. What if they used a pump to decrease the water duration? So the water duration, rather than staying a few hours, maybe one day, they are gonna be 2 or 3 hours. How we are gonna do this? So what I'm trying to do here, I'm trying to read not only the 2D functions, but I'm reading the 3D functions. Do you guys remember when we have a 3D losses with flood duration? So reading the 3D functions is a little bit difficult. I did it here on 300 lines. So I can have them in a matrix that I can do operations on. I'm not gonna ask you to write the 300 function, the 300 line. I'm gonna give them to you right away. So I'm gonna give you this 300 lines. You're not gonna write them. So here, look at this. I'm reading archetype number 1, F1. I'm reading damage state 0 up to 4, and it's a 3D, and I'm reading them from Excel sheet. Like if I want to open this Excel sheet, like here, I'm gonna give you all these Excel sheets. I'm gonna open outside MATLAB to show you. So this is I have every each archetype in one Excel sheet. Like this one is Excel sheet for archetype 1, and I have sheet number 1. It is sheet number 1. It's for damage state 0. Sheet number 2, damage state 1, 2, 3, up to 4, and I have a loss function. Damage states is 5 curves, right? Because damage state 1, 3, but the loss function is just one surface. Okay, so I have one Excel sheet for them. So what all these numbers, this is for every point on the x-axis and every point on the y-axis, there is a point. So this is the mesh. And if you look, the more that I go this way, the more the losses are increasing. So look at this. Here I have it to start from 0. The more that I go this way, the number are getting increasing until you get to the last one. It's gonna be almost 100%. So this is how loss surfaces start from 0 and go all the way up until it becomes 1. So this is for damage state 0, but if you go to F1 loss, look at this numbers. By the way, this is exceedance probabilities, so the maximum number is 1. The losses, it start from 0, and then you have 19%, 27. And if you go all the way down and all the way here, you will have almost 100%. This fraction that you have, you would say, oh, but this is not 100%. It's a little bit over. The way that I did it here, I divided the losses over the building replacement cost. So there's a little bit of fraction because maybe the number here is not because of the rounding, okay? But the maximum number is 100%. If you guys remember, the losses, there was like a lot of points here, like this. And I took the mean. So, and then I use this to get value. But anyway, make sure, because let's say at the end we are calculating losses, right? So the losses is gonna be like, let's say the building have 50% losses. So if you multiply the number from here by the building value right away, let's say the building value is $500,000, 500,000, and it gives you 50%. If you multiply it from this table right away with the building replacement cost, you have to divide by 100 because these values are 100. So you have to divide 50 over 100, so you get percentage. Because if you multiply 100 by 500,000, that is going to give you 500 million. Okay, so that's why I divide by 100 when I calculate the losses. All right. Okay, so you know the nature of the Excel sheets that we have. It has all the information that we need to calculate losses. Let me close this sheet. Okay, so I read this for archetype 1, 2, 3, up to archetype 15. And then I try to arrange them in one matrix. And this matrix is 4D. Why it's 4D? Because I'm doing a matrix that has the flood depths in x-axis, the flood duration in y-axis, and this is for archetype 1, and this is for each damage state. So we have 5 variables: flood depths, flood duration, flood archetype, and the damage state. Okay. And I did this for all the archetype, the 15 archetypes. And then I'm doing the same thing with the losses. So I'm reading elevated and non-elevated, and I'm reading them for each archetype from F1 to F15. Then I'm putting them in a 3D matrix. And the 3D matrix right now, it's a 3D. Why? Because it has the flood depths, flood duration, and the building archetype. We don't have damage state, okay? All right, and I was arranging also the flood losses, the 3D surface with elevated components. So the first one, non-elevated. The second one, I have AC, that means elevated components. And if you can see here, I only have 4 buildings that has elevated components, which are the residential buildings. The residential archetypes is from 1 to 4. Okay, so can you see around 233 lines just to organize the data in matrices so I can run my damage analysis. I'm gonna give you this code. I believe I already uploaded this code to a drive, and it's the course drive CGN. So there's a folder, I believe I shared it with you, but I'm gonna share it again. This folder, and I put the project documents. Yeah, this is the shape this is the Excel files that you need, and this is the shape files that you need. I'm gonna give you this shape file. We're gonna talk about them in a little bit. But for now, this is the Excel files that you need to read, and then I also attach it here in a Word file, the 3D fragilities and loss function MATLAB code, this code. You're gonna copy paste. I don't want you to write all this reading stuff. You're gonna write other things. So I give you over 200 lines, you just copy and paste them. Okay. All right. Let's go to the stuff that you are gonna do. All right. So here, this thing, you did it already before in Nueces County. That's the stuff that you have done it before from previous. You read the fragility parameters and you make a for loop to calculate the probability of exceedance each damage state with the low CDF. That's what we have done before from last time. And then if you want to draw the fragility, you can draw them with this code. That's already we have done it. Like you are gonna copy paste it from the one that you have done it for Nueces County. It's the same code because we are gonna do basic base damage analysis. Like if you remember for Nueces County, we read the building fragilities and then we draw them and then we calculated the exceedance probability for each damage state. We're gonna do the same thing for Lumberton. But what are gonna do extra is we're gonna do some mitigation analysis. Okay, so that's the extra work that we're gonna do. So you are gonna copy paste the code that you have done it from before and put it here. Because if I'm running a damage analysis, it's the same fragility. It doesn't matter if it's a city in California or a city in Miami. It doesn't matter. It's the same damage. All right, so I read the fragility, the 2D fragility here, and then this is a way to draw them. And here I'm reading the shape file. So the shape file is going to be almost the same to the shape file that you have read from Nueces County. So you're going to put, like if you remember, that is the code that we had from before. So you are going to read the shape file, but you are going to change the name, that name from Nueces to Lumberton. And these are going to be the same because you are reading the same fields. All right, and you are calculating the same water elevations the same way, but try to name the water elevation that you extract from GIS to name them the same names here. Like look at this field. So you want to name them, like make sure that the name here matches the one in the shape file. Because if you are trying to say, I want to get the depth in meter and extract the field in the shape file that has this name, but you named a different name in the shape file, it's gonna look and it's gonna give you an error because he cannot find a field that has this name. You can name it whatever you want. You can name it depth meter, depth feet, depth m, whatever you want, but make sure when you extract the name that is exactly the same in the shape file. Okay, so once you do all these extractions, then the loss analysis is gonna start. Let's get back. Yeah, here's the loss analysis is gonna start here. Then you calculate the probability of exceedance of each damage state and the losses. And right now I'm doing only 2D damage analysis. Why I'm doing 2D damage analysis? Because I don't include the duration right now. I assume that there's no pumping, like you don't pump the water outside your property and the water is staying as much as it can. And the 2D fragility is designed that the water is gonna stay for, I don't know, 10 days. But if you have a condition that says that the homeowner used the pump and pumped the water in 1 hour outside of his property. So yeah, I need to go back to the 3D function. So what I'm doing right now is basic 2D damage analysis. I'm not doing any mitigation analysis. So I'm calculating the damage the same way that it was in Oasis Count. Like, look at this, it's gonna be the same thing. Like if I go back to the code that we have done it before, it is the same thing. Same code. I copy paste the same code. And here the same thing, the probability of being in each damaged state and calculating the maximum probability. So if I go back to Lumberton, this one, so I'm doing the same thing, the probability of being in each damaged state and the maximum one, all right? Is that good? So right now, I'm not doing anything new. It's the same thing that we have done it before. I'm gonna do it here, just changing the names of the shape files, right? Except that I'm reading 3D, the fragility surface that I gave to you. So you're gonna take the Word file, take the code copy and put it here. And I'm gonna give you the Excel files. So you are gonna read the 3D function to them to do the mitigation, all right? Okay, so right now I have done similar stuff to Oasis County. What is new? What is new is in Lumberton, we are going to investigate some mitigation measures. What if the homeowner was able to build a flood barrier around the property? How this is reducing the flood losses? What if was able to use pumps? What if was able to elevate the water sensitive components? How we can model this? But the question that you need to ask yourself first is all the exposed buildings are gonna be able to do all these mitigation measures? Like if I assume that everyone in the city that is gonna get flooded, they are gonna do these mitigation measures. They are gonna build a flood barrier, they are gonna build a pump, they are gonna elevate the water sensitive component. Is that possible? Right? There's maybe people that are very like some people they would run. First, it depends on the rates and it depends on your income. So if you're a low income, you would definitely be like want to be able to save as much as you can. But if you are rich, you don't care. You have good insurance, you have a lot of stuff, so you just run for your life and just leave everything behind. So not everyone can apply these mitigation measures, but how we can do this? How we can model the people that they are gonna stay and mitigate, and the people that they are gonna leave everything behind and just they're not gonna do any mitigation measures. Well, if we want to model this exactly like by the book, we need to do lots of social science analysis. You need to know what is the race of the people, what is their income, what is their age, because if you are older age, definitely you're not gonna do anything. All right, so if somebody can help you or not, if you have family around or not. So you have to have all this information so that you can say this family is highly probable to do mitigation, but this family can't. And we cannot do this. We are engineers, right? So we need people to collaborate with us. So what we can do for now, so we can solve this dilemma. So to do this, what I'm gonna do, or what we are gonna do in this class, first, this is Lumberton, and this is the hazard scenario, the flood hazard scenario that came from Hurricane Matthew in 2016. All right, the city is around 20,000 buildings. Do you think all the city got flooded? No, right? There's lots of buildings. Can you tell me, can you guess a number from out of this 20,000, how many buildings that are in the flood zone? Just a guess. 10%, like what? Like what? 20,000 is gonna be 2,000. That's really good guess. So around 1,800, 1,900 buildings of the buildings that got flooded. So what we are gonna do is, well, the thing is, when we run the damage analysis, it doesn't make sense, or it's gonna be a lot of work to give the MATLAB codes lots of buildings that has zero flood depths, because every building does not have zero flood depths, the damage is gonna be zero. So what I would do exactly, I would extract the building that only got flooded. That 10% of the building of this. Why? Because I want to save time, especially if I have 500,000 building, that's gonna save a lot of time. MATLAB is not gonna take that much time. Maybe you can make, if you can make a for loop at first and say the buildings that have zero flood depths, put everything zero, it might save time. But sometimes some people would do, okay, what I'm gonna do, I'm gonna only extract the buildings that are flooded and exclude all the other buildings. and only deal with this building, the 2,000 building, rather than dealing with 20,000 building. That's one way to do it. All right, let's say we have 2,000 buildings that are gonna be exposed to flooding. How we can say that not all of them are applying the mitigation measure? How can I model this? I did it before. The way that I did it, I said, I'm going to, like, let's say that these are the buildings. Right? And they are from 1, 2, 3 up to building number 2,000. So what I did, I made a uniform distribution from 0 to 1. Okay. And do you guys know what his uniform distribution is?
Yeah.
Log normal distribution is the one like this. All right. And when we do you remember the function that we use norm rand to pick one random number that follow a normal distribution? Same thing, I can do it in MATLAB. I can do uniform distribution that can pick random numbers. And if you plot, like, let's say I'm gonna take 2,000 random numbers. If you plot this 2,000 numbers, it's gonna give you uniform distribution. So I did something similar, and I generated 2,000 number that they are gonna follow a uniform distribution. So give me 0.12, 0.109, 0.234, or a lot of numbers, and they are randomly distributed. So what I did, I want to make everything randomly. Like, I don't want to select building that I know. I want to say, I'm going to select random 10% of the building, and I'm going to say this random buildings apply the mitigation methods. So you don't select like a bunch of blocks here. So I'm going to do them randomly. So it's going to select some here, some here, some there. So I can model the random behavior of the people. All right. So what I did, I generated a uniformly distributed 2,000 number, and I said, ArcGIS, please select the buildings that has number in this field less than 0.1. And look what happened. It select 10% of the building, and they are randomly selected. So that's what I did here. I came in MATLAB, and I asked MATLAB to generate, it was around 2,800 buildings. U is the uniform, rand is the function that generate uniform random numbers and generate 2,857 random building. If I run this, let me run this alone so that you can see what this function can do. Yeah.
So if you said you extract the 10% that has flooded in it, right?
Yeah, extract the buildings that only got flooded.
Yeah, so why do we select them random? I don't understand.
You're gonna find out later. Well, actually explain. I said, the thing is, to know the people that apply the mitigation measures, you need to do lots of social science, okay? So we are gonna try to like find a way around it. Rather than doing a social science analysis, we are gonna select a random 10% of the building and say that this 10% are gonna apply the mitigation measure, and the rest of the 90% they are gonna do nothing. Okay.
So the randomly is for the mitigation.
For the mitigation, the thing is, we can select we can select them not randomly, but the thing is, it's gonna be biased. Like when we select them all, the first 10% of the building, they might end up in just one neighborhood. But this is not what's gonna happen. Maybe somebody here, somebody there. So that's why we did this random thing. And by the way, this is actually how everything in life. Nothing is deterministic. Everything is probabilistic in the whole thing. Like our loads on the beams is probabilistic. Everything is probabilistic. Nothing is certain.
But our choice of blood depth, we make an assumption it's fixed. It's not probabilistic, but randomly come from the mitigation. Does it come from?
What do you mean?
I mean, like from our analysis, we choose the 10% that has blood depth. So
Yeah,
it's
yeah,
not
yeah.
randomly choose. It's not.
No, okay, so we have 2,800 buildings that got flooded. And we picked 10% of the building out of these, like 280, random.
Okay.
Okay, so that's what we did. We picked them randomly from the buildings that got flooded.
Oh, I see.
All right. Okay, but this is assuming that only these buildings that like, the thing is, when it's gonna get flooded, you don't know if you are gonna get flooded or not. Okay, so maybe buildings outside the selected zone apply some mitigation because they don't know if they are gonna get flood or not. You know what I mean?
Yeah.
Okay, so there's some limitations, but it works here. All right, do you guys understand me? The thing is, when it's gonna get flooded, homeowners like let's say. Okay, let's get back here and let's zoom here. Can you see this building on the edge? So how this homeowner gonna know he's gonna get flooded or not, and how this one is gonna know he's gonna get flooded or not? It's like there's no way. It depends on how is the flood is gonna happen, right? So our assumption is we're not gonna say that everyone is applying mitigation. We're gonna say the buildings within the flood zone that we have are applying mitigations. Okay? Because if the flood was more than what is estimated, this guy is gonna get flooded. The one here. Okay? And if it's less than, this guy is not going to get flooded. So we are assuming that this 28,000 buildings know that they are in the flood zone, so I don't know, warnings or whatever. And out of them, 10% is going to be selected randomly and they are going to apply the mitigation measure. I'm just trying to be more realistic when it comes to mitigation.
Also the uniformly distributed. What's the x-axis, is it the buildings or like?
No, x-axis is the number, like, we are gonna have numbers from 0 to 1, and they are uniformly distributed. Actually, you can make them from 0 to 10 or 0 to 100. Okay? But at the end, if you make them 100, you want to select the building that are less than 10. Okay? Because here, like, let's say that you have 2,800 buildings. There will be here 280 buildings. 10% from 0 to 1 of the buildings. That's the magic of the uniform distribution because it's uniform. If you come at 1, you will find 20, let's say 1,000 building. So you will find here 100 building. If you take at 2, you will find 200 buildings. But if I made it uniform, it's not going to be the same thing. If you take at 1, it's going to be, this is going to be more, this is going to be more. So that's why I did uniform. Okay. All right. So that's why I did this uniform distribution. And by the way, here's how it looks like from 0 to 1. All right, so come back here. And then at the end, right now I didn't do any mitigation. I'm just preparing the shapefile for the mitigation. I did the uniform distribution. And at the end, I wrote the damage state, the probability of being in each damage state, the losses. And I also extracted the uniform distribution here. This one. And I put them in a new shapefile. It's called the flooded buildings baseline damage. So this shapefile. Let's actually put this shapefile here and see how it looks like. And I'm gonna turn off the old layer. And I'm gonna zoom. Until it loads, let me continue on the MATLAB code. So right now, I did baseline flood damage analysis, like without any mitigation, what is the damage and what is the losses is gonna be. What I'm gonna do right now, I'm gonna apply some mitigations, okay? And I wanna measure with mitigation, how much is the flood loss reduction for each building and for the entire community. So first, I have the baseline is here. When I do mitigation, I'm gonna be here. I want to know what is this difference is at the building level and at the community level. How much millions I save. All right. Okay, let's see that. All right. So look what I defined here. I told you about that. I'm gonna say that not all the people apply the mitigations, right? So that's why we made the uniform distribution. So how I did it, I said 10% applying mitigation. What is gonna happen? 20% applying mitigation. What is gonna happen? 30, 40, 50, until 100%. Okay, that's for applying mitigation. And then I investigated about what if this 10% applied flood barriers. But the thing is, everyone can put a different barrier height. Like, let's say they are gonna fill some sandbags. Some people are gonna put until 20 centimeter, 40 centimeter, 60, maybe 1 meter. So I did multiple scenarios for the barrier height, 0.2, 0.4, up to 1 meter. Flood duration, I put multiple scenarios. If the flood duration is 1 day, 2 days, 6 days, up to 10 days. You will tell me why you have 9 here, 17, 49. If you guys remember the way that we developed the 3D surface, I'm not sure if you remember or not, it was something like this. And I told you we are gonna make them up to 100 here and 100 here. So I said from flood duration from 0 to 10 days, which is 240 hours, I'm gonna divide them to 100. So step number 9 was equivalent to 1 day. And step number 80 was equivalent to 10 days. So that's the steps, okay? So when D is equal to 80, like when this number is 80, that means it's 240 hours, which is the 10 days, all right? Okay, so that's for the flood depths and that's for the flood barrier. I started defining the scenarios and I put the scenarios here. I'm gonna show the results so you know what exactly I'm doing. I'm gonna show you the final results before I continue. So let me go here to the paper that got published for this work. Disaster risk reduction. So this is one example of the flood barriers that was for, actually that's from the same city, Lumberton. And that shows in Hurricane Matthew, how was there was no mitigation, and Hurricane Florence, there is a flood barrier around. And this is the framework for the mitigation. I might share this paper if you wanna see the sequence. And this is the bumps that has been used to decrease the flood duration, really big bumps. And this is an example of elevating the water sensitive components. And this is the new elevations, the old elevation and the new elevation. Okay, so this shows you the impact of using a flood barrier. If you guys remember, this is without a barrier, but if you have a flood barrier 1 meter and the building there's 1 meter around it, so the flood losses is 0 until the flood depth exceeds the barrier height, and then you will jump back to your original fragility or loss function. And this is if you have flood duration, so this is like 1 day, 2 days, 6 days, 8 days, whatever. So you take sections, and this is how the loss function look like. The more the flood is gonna stay, the more the losses can go, right? So this is the methodology, and I'm gonna show you the results right now. And this is the impact of elevating water sensitive components. That's what we draw here, if you guys remember. Okay, and this is combination between elevating water sensitive components here and the flood duration. So if you have two at the same time, so I did some combination of mitigation. What if you used bumps and elevating water sensitive components and barriers? So, and here I'm showing my flood simulation. And here's the combination. I did 320 mitigation scenarios. Look, I investigated flood barriers and bumps, and this is the barriers, and this is the pumping scenarios. And I did bumps with elevating water sensitive components, and did barriers with elevating components, and did barriers with bumps, and I did all of them. And by the way, all these mitigation measures has been applied to 0%, 10%, 20% of the building, up to 100%. Can you imagine how many scenarios? Like I did this with this, and the whole 10, and this was the whole 10, this was the whole 10. Many scenarios. Okay. And here, I want to show the final curves. This is how the final curves look like. So this is, for example, showing you the impact of barrier height. And if the barrier is number 1, scenario number 1 is 0.2, 0.4, 0.6, 0.8, up to 1 meter. Okay, so that's scenario number 5, 1 meter flood barrier. And this is if the zero of the building applied mitigation measures, that means the losses is $132 million. But as soon as more people apply mitigation measures up to 100%, the losses can go down until like $87 million. So you are saving, I don't know, over $14 million in flood losses. If the 100% of the buildings are applying the barrier. This is for the pumps. You pump the water, scenario number 1 up to scenario number 5. That's the curves that I'm looking for after you finish the analysis. But let's get back to the MATLAB code to see how we can get this results. All right, so first I define the scenarios that I have, and then I'm reading the verse shapefile. And look, how did I name the shapefile? Before, I named the shapefile S. Like if I go back here, I read the shapefile S, shape read, flood buildings. Right now, I have 10, let's say 9. Why I said 9? Because I already the 100% is the whole base. Like if I say 100% of the building, that's all the building. So I already did the baseline flood. So I do from 10%, 20 up to 90%. Okay. So right now I'm reading a shapefile that has 10% of the building. How can I get the 10%? Look what I'm gonna do. I'm gonna go to the shapefile. Oh, it's still loading. Come on. All right. So that is, it doesn't have the uniform distribution. Should be here. Oh, that's flooded buildings baseline damage. Anyway, maybe I would give you the shape files. I'm gonna give you the 10 shape files. These files that has, you will find some of them has 10, some of them has 20, some of them have 30. So you are gonna take this shape files right away. I'm gonna send them to you. You don't have to generate them. So each one is gonna have a number in front of it, and each number represent that is 30% of the buildings. And if you found 40, that means it's 40% of the building. So every shape file is gonna have different number of buildings. Okay, so the big one, the 100% is like 2,800, but the 10% is gonna be 280 buildings. That's why I couldn't make a for loop that can go through the same process. Like you'll tell me, why did you copy paste the same code 10 times? Because I was running the analysis for each scenario, 10%, 20%. So why you didn't make a for loop that can do the same thing 10 times? Because every loop has different numbers of buildings. Loop number 1 has 280. Loop number 2 has 2 multiplied by 280. Loop number 3 is something like this. So that's why when I came here, I did the analysis number 1 on archetype number 10. Okay. Sorry, on shapefile that has 10%. So I read this shapefile, I read the flood depths, I read everything here. And I once I have done this, by the way, you are gonna do same thing that like the reading of the shapefile that we have done it before, right? And then you calculate the flood depth is, and then you make the flood depths that are less than 0. Like if you have a flood depths that are negative, make them 0. And then here, I'm defining some matrix, or I'm preparing some matrices to fill them. Do you remember when I told you we prepared the matrix before the calculation? So I'm gonna calculate a matrix that is gonna have the loss for barrier number 1, that is 20 centimeter, for 10% of the building. And I'm gonna do the same thing for barrier number 2, which is 0.4 meter, for 10% of the building. So that's the scenarios. So that is gonna have the losses for each barrier for the 10% of the buildings. And I'm gonna do another one that has the loss reduction. So what is the difference between loss and loss reduction? The loss is the one that we are gonna calculate from here. This is base, and this is the scenario. The loss reduction, you are gonna calculate the difference. So in the new matrix, you are gonna put the difference between the base and the mitigation so that we know how much did we save. And this is gonna be for every building. That's why you will find here is a matrix. Then at the end, I wanna know how much loss reduction total for the entire community. And this number is not a matrix, it's just one single number. Why? Because I'm gonna sum all the flood loss reductions for the 280 buildings and sum all of them together and give one number. I wanna see how much millions I saved for the entire community. So I'm preparing these matrices because I'm gonna fill them right now. So that's why I named them and I put zeros. And now I'm gonna start the analysis. So here I'm starting a for loop. This for loop, the first thing that it's gonna do is gonna run analysis at the lengths of the shapefile that I have. If I have 280 building, I'm gonna put here 280 building. That's why I told you I can't make the same for loop for every shapefile because every shapefile has different numbers of buildings. So this number needs to be different for each one. So rather than I put 280, I put the length of the building S10. And by the way, I created this thing in a way that I can copy paste and I can replace the 10 and make it 20. So you will find right now, if I have this done and I want to do the same process for the 20% of the building, you're not going to write the code. You're going to copy this code in a separate MATLAB file and search number S10 and replace it with S20. And then you paste it again. And you do the same process 10 times or 9 times. So you don't have to write the same code again and again. For example, let's say I'm doing this mitigation for 10% of the building. Look here, I'm doing the same analysis for 20% of the building, writing the same code. And it's around like 200 lines. And another one for 30% of the building. Look here, 30. And you scroll down, you will find I'm writing the same code again for 40% of the building. So how can I do this? I'm gonna take just this piece of code. For example, I'm gonna take a Control-C and I'm gonna put it in a new one here. And I'm gonna say Control Find, and I'm gonna replace any name that has S30 and replace it with S40, for example. And I'm gonna say replace all. So that's why the organizing the code makes you more efficient. And then you're gonna take a copy paste and throw it, and you do it for S50. Copy paste and throw it. Yeah.
Don't you want to also replace the shape read file with 40 or?
Yeah, you should. Did it replace?
It didn't replace it. No.
Oh, because it doesn't have S. You know, if I have here S, so it could have done it better. Like, so I have to put S here. Oh yeah. All right, let me go home. Settings. Phones. Oh, that's very big. Let me make it 14. Is it much better now?
Yeah.
Okay. So yeah, I mean, maybe, yeah, that's why if you name it in a different name, it could have solved the problem. Okay, but I mean, like I can change it by myself. So yeah, so I have everything just a change and I can do it again and again and again. So you only write it one time, and the other time for the other scenarios, I'm just gonna find replace. Okay, so let's get back here. Yeah, I'm gonna explain the code because I didn't explain it. So let me go back here. All right, I have the scenarios for the flood barriers and the scenarios for the flood depths. Let's start with, let's say that 10% are only applying mitigation measures. So I read the shapefile that has the 10% and I read the flood depth and I read everything so I can do the damage analysis. And the thing is, what I did here, I told you I made all these zeros. Here I'm starting the loop. And I'm saying, if you guys remember, we have two special archetypes, archetype 1 and archetype 3, right? So that's why I'm making an F statement is special for archetype 1 and 3. Do you guys remember why 1 and 3 is special? Because it has a crawl space foundation and the flood depth is measured from the ground. Other archetype, the flood depth is measured from the FF. So that's why you will find an F statement just as special for these. And by the way, you can copy paste the same thing again and just replace that they are not archetype 1 and 3. Like if you go here, you will see once I finished the F loop, this F1, and I go down, there is else here, and do the same thing again for other archetypes, except when you do the interpolation, use the flood depths measured from the FE. Okay, so let's get back up there again and see what we have here. The first line of code here, the first line, I'm calculating the base flood loss without any mitigation. Okay, I'm saying it loss base, and I'm interpolating in the 3D function with, by the way, I'm doing here loss analysis, not fragility. So I'm not using the fragility. Why? Because I'm not interested in damage. I'm interested in value of losses, dollars. So I'm using here all loss functions. There is no fragility. So I'm interpolating in the 3D loss surface. So when you do interpolation, like let's say, okay, let me get it. Not sure if I have it here as a surface. Well, the thing is, we're gonna do interpolation right now, but the thing is, you would tell me why you are doing 2D interpolation in a 3D loss surface. I somehow tweak the interpolation to be 2D. So I could have like I would have done this. I could have told MATLAB, I want to do 2D interpolation at a flood depth 2 meter and a flood duration of 300 hours. Okay, so it's basically it's gonna come here and go here and get the point. That's the interpolation. But what I did is different. I said I'm gonna do 1D interpolation, but try to cut in this surface at a specific flood duration and go interpolate in the curve that you cut it. Okay, so I did 1D by cutting in this surface. So how did I do this? I came to MATLAB and I did here, look at this, interpolate one that's 2D, all right? It takes the flood depths and takes the 3D loss surface. And if I look here, the flood loss surface, if you guys remember, it's a 3D matrix that has X and Y and the building archetype. Okay, that's how we built the it was like a 3D matrix. And I'm saying here for each of flood depths, and here I converted the 3D surface to 2D surface. Why? Because I cut it in this surface at D equal 5. What is D equal 5? It is the flood duration at this line. So basically, I came here and I said, let's see, what is D equal 5 equal to? D equal 5, that means 80, 10 days. So I basically, but if I put 2 dots here, that's going to be the whole surface because you are saying for all the points in the D direction. But since I put D5, that means I'm only interested in the numbers that are in D5. But if you put the 2 points, that means that you are interested in all the durations. Okay, so that's why I converted. You can do 2D as well. Like if you can do the same thing 2D, but I prefer to do the 1D interpolation. All right, so I'm interpolating in this surface and take the flood depths measured from the ground elevation and go inside this surface at the flood depths and calculate what is the loss value. And when you calculate the loss value, multiply by the building value and then divide over 100. Do you guys know why we divide over 100? because it's 100, it's not percent, it's 100 values. So it's gonna be 50 over 100 is gonna be 50% and multiplied by the building value. So right now I converted, let's say if I didn't multiply by the building value, what is the value that I'm gonna get? It's gonna be percent, it's gonna be like 50 or 20. Okay, but let's say I put over 100 without the building value, it's gonna be 0.5 or 0.2. Once you multiply by building value, it's gonna be 0.2 multiplied by 500,000, and it's gonna be a value like $50,000. All right. Okay, so this is how I calculate the base flood losses. This is without any mitigation. Let's see how I did the mitigation. Very simple, very easy. I said, if the flood depth is less than the barrier height that we are investigating right now, which is HB1, the 0.2 meter. Okay, if you have a barrier 0.2 meter and your flood depth is less than the barrier height, what is the amount of losses? Zero. But what if the flood losses is more than the barrier height? It's going to be the basic flood loss. So I said if the flood depth is less than the barrier height, the flood loss for barrier 1 is 0. But if not, do the same interpolation again and calculate the basic flood loss. This one. Okay? All right. And I did the same thing again. Yeah, here after I finished this step, I calculated what is the amount of flood loss reduction. I told you we're calculating the loss, the total, this total, and this one, the base, like here and here, okay, for each building. Then the next step, I'm gonna calculate the loss reduction. How? I subtract the loss from barrier number 1 minus the loss from the base minus the loss from barrier 1, okay, for each building. It's gonna give me this value for each building, right? So that's what I did here, the loss reduction. And then I did something, it's called the loss total. And look here, I don't have matrix for the loss total because it's just one number. I said, once you calculate the flood loss reduction, put it here, okay? And then every loop keeps summing them on top of each other. Like once you finish, the thing is, look at this. Let's say that we calculated, we are starting the analysis. So the flood loss reduction is 0, right? Before we start the analysis. So loss reduction total, the start one is 0 because we define it as 0. And then we calculate the first loss from the first building, it gives us like $50,000. So we put it here, 0 plus $50,000 is going to be $50,000. Then you run another loop. By the way, when you put 0, look, this two is the same. When you put 0 plus $50,000, it's going to give you $50,000 here. When you run the second loop, your starting point is 50,000, and then plus 20,000 come from the next building, so you are going to be 70,000. So basically, this one is keep summing on top of each other. Every loop is stored in the loss total, stored in the loss total, until at the end of the loop, here you are going to have all the losses from all buildings. All right, so we have the loss total, and once I finish, HB1 is the barrier number 1, this one, which is 0.2 meter. I'm gonna go next to barrier number 2, which is 0.4 meter, and do exactly the same thing. And by the way, you can copy paste. Like what I would do, I would copy the same code from barrier 1 here, this one, until like this code, and do it the same thing again here. If the flood depth is less than barrier number 2, put 0, and then calculate the flood loss, and then calculate the flood loss reduction, and then calculate the flood loss total. And do the same thing for barrier number 3, barrier number 4, barrier number 5. And once I finish the 5 barriers, I have to do the same loops again, because if you remember, this is only was for archetype 1 and 3. So we are going to do another loop, another statement if it's for any other archetype, if it's for archetype 2, 4, 5, whatever. But the difference is archetype 1 and 3, look, all the flood depths are measured from the ground elevation. Here is the same thing, but the flood depth is measured from the FFE. So when I did this code, I wrote this one, and after I finished, I take this code separately from this line, Control C, and I took it here, and I made Control Find, and I replaced the ground elevation with FFE. By the way, it took me some time to rename this consistently so it doesn't catch with any other thing. So if I replace all, let's see what we have. You'll find here has FFE, here has FFE. They all have FFE now, rather than the ground elevation. You can do whatever you want, but I'm just giving you tips how to do it efficiently. All right, so once I done this, I did the same thing for all the building archetypes. And here I have FFE, and I did the same thing for barrier number 1, barrier number 2, 3, up to barrier number 5. And I keep calculating the same thing, the flood loss, the absolute flood loss, and the flood loss reduction, and the total flood losses. Then at the end, once I finished by the way, this is only for 10% of the building. They didn't get to the 20%, okay? So this is how we do it. For the 10% of the building, we have the base flood loss, and then the flood loss that comes in from each barrier, okay? Then I put them in a matrix. So I put the flood loss reduction total for barrier, like look here. I made a 2D, actually this is a 1D matrix. It's for the 10% of the building. I have 5 scenarios, 1, 2, 3, 4, 5. Each scenario has the flood loss reduction total if the whole community use flood barrier 20 centimeter. And scenario number 2, if the flood barrier is 0.4 meters. Scenario number 3, scenario number 4, scenario number 5. And that gives me the numbers that I need to use for this curve. Scenario 1, 2, 3, 4, and 5. Okay, and by the way, this is only if 10%. Where is the 10%? This line. So the value from this for loop give me 5 points to draw this mitigation line. By the way, if I have 0 of the building applying mitigation, so it's gonna be the base flood loss. There's no loss reduction. It's gonna be this. But once 10% of the building, it is targeting like this. That's for 20%. So I want to do the same thing for 20% of the buildings. I told you how to do it. Basically, 2 minutes ago, I told you to copy this code. And actually, I have it here. This one. And you put, like, for example, S40. And you replace it and put it like S20. And I did replace all. So you're having S20s ready. And make sure that you have this S20. All right? And you run and you copy this code and you put it here for the 20%. What does the second code do? The second code is making the same thing like the code from before, but rather than having 10% of the building, you're having 20% of the building applying this mitigation measures. Did you guys got that? Yeah. All right, so it's only one piece of the code. And by the way, there is lots of stuff that you can do copy paste in the same piece. So once you finish this piece, you can copy and replace, copy, and then find and replace, and then copy and paste and put it down here. So right now we only finished if we are gonna apply flood mitigation using flood barriers. And look here how many lines when we get to the S100. S100, we are in the line 1682. And by the way, you will find, oh, that's like hundreds of lines of coding. It's not that way, okay? So we all know what is the secret, all right? And you all know right now why I didn't make a for loop for this repetitive process that we copy paste, because the length of the data is not the same. If the length of the data is the same, I could have done this, all right? And by the way, there's a way that you can get around it, but I didn't try it. Like you can have the original shape file and you can make fields, okay? And in this fields, you can make 0 and 1s. So if like you are gonna sing in the same big one that has the 100% of the building, I can make one field that it says S10 and one field say S20, S30. And the selected buildings are gonna be 1 and the non-selected buildings are gonna be 0. And you're gonna make a for loop that can do the whole process in one for loop. And in the same for loop, you say, if you saw 0, put everything as 0. Or put everything as the base, right? And then only do the analysis for the one that has 1. So that's a one way to do it, if you guys wanna try it. But at that time, I found this approach is easier, okay? All right, so this is your first task towards your project. And by the way, look at it that way. It's not that much coding. You already wrote the damage analysis part from other code. You're gonna take a copy, paste, and replace. I'm gonna give you all the reading codes that to read the 3D. I'm gonna give you all the data. All what you have to write right now, I believe if you have done all the stuff that we have done before, is that flood barrier for the 10%. And everything is gonna be copy paste, all right? Okay, next time we are gonna do the mitigation analysis using water pumps to decrease the flood duration. All right, does anybody have any questions so far? All right, okay, sounds good. See you guys next time.
This one is almost 6,000 lines, but assume.
No.
Just complete about 16.
1600, that's for until the flood barriers.
Okay.
Starting from here, we're gonna investigate the durations.
Okay. For this
Okay, next lecture, yeah. All right? Okay, sounds good. If I didn't upload the data today, somebody send me an email. I try to upload it at night. So I upload all the Excel file and the shape file.